Okay, part number 2, the part we did today, Monday. This one was the vectors and the polar stuff and the conic sections. So number 8, you're finding the magnitude and the direction angle. Oh man, I turned my calculator off. Let me turn that back on. Kind of need that. There we go. So magnitude is just the Pythagorean theorem. So in this case, so you can call it whatever. So like it was written as like that, the absolute value. So the magnitude of vector v is just going to be the square root of, and then just square your two values. As we mentioned in class, feel free to leave the negatives on or take them off because you're going to be squaring them regardless. So 5 squared plus 9 squared would be the square root of 25 plus 81. Highlights, James. You want to listen to pre-calculus? Okay. So that's the square root of 106. And that actually does not reduce, which hurts my feelings. But that's the magnitude. So the magnitude of number 8 is the square root of 106. Now to find the direction angle, that's just SOHCAHTOA. And if you recall, we did use tangent. And just like we did a minute ago, the tangent of the angle is y divided by x. Alright, and again, obviously this is still x and y. And they do want it in degrees. Pardon me, rounded to the nearest tenth. So since I'm looking for the angle, I'm going to, in my calculator, I'm typing in the inverse tangent of, and you can use -9 over -5. I'm probably just going to type in +9 over 5 because I know that a negative divided by a negative is a positive. So let me type that in. Inverse tangent of 9 over 5, rounded to the nearest tenth. Pardon me. My calculator is telling me that's 60.9 degrees rounded to the nearest tenth. Okay, so that is the magnitude and the direction angle. Number 9 is the dot product. The dot product, remember, you're just going to take your two x values and multiply them. 6 times 5. Plus, then you're going to take the two y values and multiply them. 9 times 4. And add them. So that's going to be 30 plus 36. Or 66. So that's number 9. Alright, now number 10 is an angle between formula. I'm going to scroll down to do this one because it is a little steppy.
I love you, Mom.
What, buddy?
I love you.
I love you too, man. I think that was 9j, and the other one was the square root of 5i, and then just plus j. Make sure I had that right. 5, 9, yeah, okay. Alright, so the formula for this one was cosine of theta is the dot product over the product of the two magnitudes. So it's not that it's hard, it's just real steppy. Okay, so let's do the dot product first. And so just like the one that we just did, I'm going to take the two x values and multiply them. So the square root of 5 times the square root of 5 plus, take the two y values and multiply them. -9 times 1. So that's going to be 5 plus -9 or -4. So -4 is my numerator. And then I've got to do the two magnitudes. Again, I'm going to do those individually. It really doesn't matter as long as you do them both. So I'm going to do the magnitude of the first one. Would be the, remember that's just, my pen's being weird. The square root of the square root of 5 squared plus -9 squared. So that's the square root of 5 plus 81. Which is the square root of 86. Now that might reduce, I don't know, and honestly it doesn't matter because I'm about to put all of this in my calculator. So I'm just going to leave it like that because why would I bother? Because I don't need it. Alright, so I'm going to do the magnitude of v as well. Same thing. So I'm going to do the square root of 5 squared. What, buddy?
Like, is that recording your voice, kind of?
Yes, it is recording my voice, which means they're going to get to hear you too.
Yeah.
So that's going to give me 5 plus 1, which of course is just the square root of 6. So that's going to be times the square root of 6. Okay? Now, this right here is what's going to give me my answer. And just like the tangent from a second ago, I'm looking for the angle. So in my calculator, I'm typing in the inverse cosine of -4 over, and I'm typing it just like this, like I showed somebody. Maybe it was Titus today. But that's literally what I'm typing in my calculator. So let me do that now. So inverse cosine of -4 over the square root of 86 times, not plus, times the square root of 6. And rounded to the nearest tenth is 100.1. So let me write that up here. So the angle is 100.1 degrees. That's the angle between those two vectors. So those are the two vector ones. Alright, number 11 and 12 are the ones that are the polar graphs. 11 is a rose curve. And your job is just to tell me how many petals and their length. Super duper easy. The number in front is the length. So let's do that one first. So the length of the petals is 2 units long. Now the number behind the sine or cosine that's in front of the theta, there was a rule. So if you have your paper, like if you remember, I gave you a note guide. Go back and look at it. It's got each one of the graphs and had it all broke down. Hopefully you still have that. But go back and look at it. If this number is odd, then it's whatever that number is. So 3 is odd, so that means there are 3 petals. If the number is even, you have to double it. So like say if that was a 4, then you would actually have 8 petals. So be careful with that, but that's what you're doing on that one. Number 12 is going to be a limaison, and your job is to figure out, what the equation is. We're just matching it to the correct equation. I figured that would be the best thing to do on this one. Very similar to what we did whenever we had this test. So remember, sine, like here you can see sine and the cosines. So it's not A, because sine would be like, sine is on the top or bottom, right? And it would be negative down here and positive up here. So this one's going to be cosine, obviously, because those are your other 3 options. And obviously they're all minuses because it's on the left. Alright, cosine's over here, and positive cosine would be over here if you're looking at your graph. Now, as far as the different kinds, remember there was one that was with a loop. There was one that was a dimple. There was one that was a cardioid. This one happens to be a cardioid. Because remember, it's got like that little V shape to it. It looks like a butt. So go back again and look at those rules, because these numbers right here, that's a 1 technically, and a 2, the 3, right? Their ratios is going to determine which one it is. Now this one happens to be B because it's a cardioid, right? I can see that it's
like a butt.
Thank you, Elias James. Because these two are equal. So if A equals B, then we know it's a cardioid, and your answer is B. So go back and look at that paper. Alright, so the last 3 are the conic sections, which are the ones that we literally just finished. And just like on your quiz, do you mind? I'm going to change this. I'm not going to ask you to find the focus and the directrix or the vertices and the foci or the vertices. I'm going to change, so we're finding the vertex. So let me get that out. Of this one, and the focal width, the value of A, and the direction of opening. Just like what we did on quiz. I will give back to you on Thursday. Or if you come by and see me on Wednesday, you can get it then too. It's fine. So this is obviously a parabola, right? It says so. So that on the parabola, so the vertex Remember, the h is with the x and the k is with the y, and it's opposite. So it's going to be positive 8 and positive 6. Remember that the number that's in front of the parentheses is 4a. So if 16 is 4a, divide 16 by 4, a is 4. The focal width is the number in front of that, remember? So that's going to be 16. Ooh, wow. And then the direction of opening. Okay, so x is squared, and this is a positive number. X is squared, 16 is positive. This is going to be a facing up parabola. Okay, so hopefully, again, you have all your notes on that. If not, they are posted on Google Classroom. You're more than welcome to go glance at those. All right, so for the ellipse, I am going to ask for the center, and then the values of A, B, and C, and then its orientation. In other words, is it tall or is it wide? So this one, notice how I'm not adding or subtracting anything to the X or Y. So the center on this one is the origin. So it's 0, 0, because again, I'm not subtracting. I don't have an H and K. A has to be the big number. Remember, A has to be the big number in an ellipse. So you want to take the square root of these two. So A would be 10. Oops. And then B would be 6. So those are super easy to find. My brain is off, y'all. It's 6. Now you do have to find C. I'm going to scoot down here and do that right here. So this is for number 14. So to find C, it's the A squared equals B squared plus C squared. I know, almost the Pythagorean theorem, not quite. So that's what you're going to use to find C. Totally okay if it's a decimal. This one happens to not be, but like it okay. Don't freak out if it is. So that's 100 equals 36 plus C squared, right? A squared and B squared. So obviously I'm going to have to subtract 36 from both sides. That's going to give me 64 is C squared. So if I take the square root of 64, I get 8. Again, don't forget, you're taking the square root of Pythagorean theorem. Super easy. So that means that C is 8, which would give us the foci. And A and B are the ends of the vertices. So, I mean, that's why I'm more focused on that. And then the orientation. Okay, so the big number is under the X value. The big number is under the X value, so that means this is a wide. It's wide. My little egg there. So it's wide. So the big number A is under X. So it's a wide ellipse. 15, last one. Same thing. Like, I'm not going to ask you for the vertices and the foci. I'm going to ask you for the values of A, B, C, and then again the direction of how it opens. And then I'm also going to ask you for the center. I don't know why that's not listed in the directions, but it's just like our quiz. So here we go. So let's find the center first. Now be careful. I mentioned this in class because I would be the person who would mess this one up. Please note that the H is with the X and the K is with the Y. It's backwards, right? It's the X isn't first. So the center for this one is -2 and -4. Again, make sure you change those signs as you pull them out of the parentheses. All right, on hyperbolas, A can be the big or little number. It doesn't matter, but it has to come from the first number because notice subtraction, right? Order is important on this one. So A is the square root of 64, which is 8. B is the square root of 36, which is 6. So for number 15 to find C, it is the Pythagorean theorem. A squared plus B squared equals C squared. This one happens to honestly just coincidentally be the same numbers as number 14, but let's do it anyway. 64 plus 36 is C squared. That's going to be 100. So So that means that C is 10. C is 10. All right, because you got to do that square root there. So I found the center, the values of A, B, and C, and the direction of opening. Okay, so the direction of opening, remember, for an a hyperbola, is determined on what comes first because of that minus sign. So the y squared is first. So since the y squared is first, this is an open up and down hyperbola. It would be one of those. So it is an up-down hyperbola. And there you go. You guys let me know if you need me for anything.